Hey, someone asked me to go over the capillary filtration and absorption from Heart and Circulation 4 and 5. So I'll ask you to go back to chapter 2, and I'll quickly remind you of this core concepts where there are two compartments, A and B. You're given the hydrostatic pressures of both and the osmotic pressures of both. And you just plug them into the equation to determine the flow direction. And so let's say you're using, A as a reference point here. You'll do hydrostatic pressure A minus hydrostatic pressure B. And that whole thing minuses osmotic pressure A minus osmotic pressure B. And here you'll get, positive 35. And what that means is there's an outward flow from compartment A. So it's going from A to B. And let's say you're using B as a reference point, it'll be hydrostatic pressure B minus hydrostatic pressure A. And that whole thing minuses osmotic pressure B minus osmotic pressure A. And that'll give you negative 35. And that means there's an inward flow towards compartment B. So it's the same thing. In both cases, the flow is still from A to B. And so for the capillary filtration and absorption, it's the same principle. The only difference here is you'll have the filtration coefficient, which is, the capillary permeability in the area of the capillary walls. This number should be given to you, because how would you know that? And compartment A and B can be thought of as capillary compartment and interstitial fluid compartment. And this is the equation. Sorry, there are question marks there. It's supposed to be pi symbols. So it's just the same thing. Net hydrostatic pressure minus net osmotic pressure gives you the fluid filtration rate. And in this case, the capillary will always be our reference point. So a negative rate means there's absorption, and a positive rate means there's filtration.